September 27, 1881. Somewhere in the South China Sea, off the coast of Luzon, the captain of a merchant ship writes a note in his logbook about a drop in atmospheric pressure he can't quite explain. He has no way of knowing it, but that casual entry, written by candlelight, will become one of the only surviving records of the first moments of a disaster that doesn't have a name yet. In 1881, the world has no satellites, no radar, no way at all to look down on a storm from above and warn people to prepare. The only way to know something is brewing out on the ocean is for a ship to sail through it, survive, and make it to port to tell the story. Days after that logbook entry, a French colonial port in northern Indochina is about to stop being the place its people knew. It won't vanish from the map, but the life it had before that October night will never come back the same way. And for more than a century, humanity would remember that night with a number that supposedly made it the second deadliest natural disaster ever recorded: 300,000 dead. If that number were true, we'd be talking about an event more lethal than almost every earthquake we know of, more lethal than most 19th century wars, more lethal than nearly any famine in the modern history books. But there's a problem nobody managed to solve for more than 100 years, one that only started coming undone about a decade ago. The town that, according to legend, lost 300,000 lives in a single night, had, at the time, fewer than 20,000 residents. This isn't a rounding error or a reasonable gap between competing estimates. It's a figure 15 times larger than the entire population of the place where the disaster supposedly happened. And yet that impossible number traveled for generations through encyclopedias, textbooks, official rankings of the worst natural disasters in history. Almost nobody stopped to do the most basic math. By the end of this video, you'll understand exactly what happened with that number, how it was born, who kept repeating it without question, and how a statistical lie managed to survive 130 years without academia, the media, or the institutions that compile this data ever bothering to check it against the original source. To understand how this happened, we have to go back to where it all started. Haiphong in 1881 wasn't yet the industrial city we know today. It was a young port, still under construction, sitting on the delta of the Red River, in a territory France had recently started calling Indochina as part of its colonial expansion into Southeast Asia. This wasn't a major metropolis. It was a recent settlement, built up on marshland reclaimed, bit by bit, from water and mud, connected to the Gulf of Tonkin by a relatively narrow channel, a channel that in the years that followed would become both the source of its commercial prosperity and, within a matter of hours, the exact mechanism of its destruction. Picture that port on an ordinary day before the storm, wooden junks coming and going with the tide, sampans loaded with fish, rice, goods moving through the delta's canals, fishermen whose families had worked those same waters for generations, who knew every bend of the river and every subtle shift in the color of the sky. And alongside them, French colonial officials freshly arrived in white uniforms designed for a completely different climate, still learning to live in a tropical environment that doesn't forgive improvisation. Bamboo and thatch houses next to the first brick buildings put up by the colonial administration, two worlds sharing the same swampy ground without fully understanding it. Around that port stretched the true economic and human heart of the region, the Red River Delta. Mile after mile of rice paddies sitting almost at sea level, protected only by earthen dikes built year after year, generation after generation, by Vietnamese farmers who had learned to live with the river's normal floods. Dikes built for the usual monsoon rains, for predictable flooding, not for what was coming in from the sea. And that detail, the port's location, which might sound minor, is exactly why what was about to happen would be so devastating. Haiphong sits about 10 kilometers inland, but it's connected to the Gulf of Tonkin by a channel that, under normal conditions, works as a safe, sheltered trade route. The problem is that same channel, when conditions change, behaves like a funnel. Water pushed in from the sea has no easy way to spread out or retreat. It piles up, concentrates, and looks for a single path forward, straight toward the city and the delta surrounding it. Somewhere in a French colonial office, while all of this was still just a distant possibility, an official taps a brass barometer on his desk, as if trying to confirm the instrument isn't malfunctioning. The needle is moving in a way that doesn't match what's expected for this time of year. Nobody in that office knows yet that, more than 800 kilometers away, over the warm waters of the South China Sea, a system is forming that will completely change this city's history within days. On September 27, 1881, a cyclone is spotted east of Luzon Island in the Philippines. It's worth pausing on what detecting a cyclone even meant back then. No weather satellites, no hurricane hunter aircraft able to fly into a storm and measure its intensity from the inside. No early warning system in anything close to the modern sense. The only way the world in 1881 could learn a typhoon was forming out at sea was if a ship had the bad luck to cross its path, survive the encounter, and make it to port to describe what it saw. 3 days later, on September 30th, the system hits Luzon with considerable force. The destruction across the center of the island is severe. Hundreds of people die, though the rest of the world barely notices. In 1881, disasters in the Asian colonies rarely made it into the London or Paris newspapers as more than a brief mention buried on an inside page. The life and death of entire communities on the other side of the world got reduced, for European readers, to a single wire service line without much detail. But here's a question worth asking. Why does a typhoon that has already killed people in the Philippines become even more dangerous after making landfall? Intuitively, you'd expect a storm to lose strength hitting an island. Friction with land should weaken it. And in plenty of cases, that's exactly what happens. But the reason it didn't happen here has to do with something modern meteorologists call re-intensification over warm water. Nobody in 1881 had the vocabulary or the instruments to describe that process, but the physics happened exactly the same, regardless of whether the science of the time could name it. After hitting Luzon, the system crosses the South China Sea, passes dangerously close to Hainan Island, and instead of losing energy the way you'd expect after a recent landfall, it gains strength again, feeding off the warm waters of that stretch of ocean. In simple terms, a storm that should have been weakening was instead gearing up for a second, even deadlier strike. On October 5, 1881, the typhoon enters the Gulf of Tonkin, heading straight for the coast of what was then known as Dai Nam, the name Vietnam carried under the Nguyen dynasty before the French protectorate was fully established. Modern reconstructions, based on the few surviving pressure and wind records, point to winds of somewhere between 150 and 167 kilometers per hour, with a minimum central pressure of around 957 hectopascals. Translated into today's scale, that's roughly a Category 2 or 3 hurricane, though for the HAIPHONG of 1881, that kind of classification didn't even exist as a concept. There was no word yet for the scale of what was approaching. When the typhoon finally makes landfall, the very channel that had made Haiphong's port prosperous, the one that safely connected the city to the Gulf of Tonkin, becomes the perfect pathway for the storm surge to push inland with full force. The water, driven by hurricane-force winds, has nowhere to escape sideways. It can only move forward and upward, over the city, over the port, over the entire delta surrounding it. The surge is estimated to have reached about 3 meters, combined with torrential rain falling across the whole region at the same time. The earthen dikes that had protected the delta's rice paddies for generations, built for a tropical river's normal floods, simply weren't built to withstand anything on this scale. They gave way one after another, and within a few hours, kilometers of farmland became indistinguishable from the Gulf of Tonkin itself. And here's a detail almost no surface-level retelling of this event bothers to mention. Most of the people who died that night didn't die at sea, weren't crushed by a collapsing building, weren't swept away by a wave they could see coming. They drowned inside their own homes, in an agricultural delta where nobody, not even the most experienced farmers, expected salt water from the sea to reach that far inland. It was a betrayal by a landscape that, until that point, had always been considered safe. The junks and sampans that supported much of the region's fishing economy ended up capsized, smashed, piled against what was left of the docks. The colonial buildings, put up quickly and without any real experience building for a tropical climate, collapsed under the wind exactly the same way the modest bamboo and thatch fishermen's houses did. The supposed solidity of European architecture offered no advantage at all against the force of that night. Within hours, Haiphong had completely stopped functioning as a port. In total darkness, with no artificial light to help anyone get their bearings, entire families tried to move through water that, in many stretches, reached their chests, carrying their children in their arms, with no way of knowing which direction higher ground was, or whether that higher ground would still be there when they reached it. When the Typhoon finally moved north, toward the Korean peninsula, and then Japan, it left behind a completely flooded delta. The rice paddies that formed the region's food base were left covered in salt water, which meant, for the months that followed, widespread hunger even among those who had survived the storm itself. The catastrophe didn't end that night. It was only beginning a second, slower, less visible phase, just as deadly in the long run. And this is exactly where the second story in this video begins. Because what happened in the weeks that followed, with the numbers attached to this tragedy, turns out to be almost as extraordinary as the storm itself. The first reports from the French colonial administration mention a death toll that modern historians, after reviewing the available archives, estimate at around 3,000 people. That's a terrible number, a real, undeniable human tragedy. But compared to what would later show up in the history books, it looks almost modest. In that same colonial report, in the very same document, there's another completely different figure. The material damage to the region's rice crops is estimated at 300,000 piastres, the French colonial currency in use in Indochina at the time. Two numbers, written in the same document, right next to each other. One measures human lives lost. The other measures economic losses in a currency almost nobody remembers today. And those two numbers, harmless enough on their own, were about to get mixed together in a way that would travel for more than 100 years without anyone stopping to correct it. The original report crossed the ocean to Europe. It got translated out of French into other languages. It was summarized for newspapers, reprinted in meteorological reports, folded into the first systematic compilations of 19th century natural disasters, at a moment in history when science was just starting to try to catalog and compare catastrophes worldwide. And somewhere in that process of translation, summarizing and reprinting, someone whose identity was never established for certain turned 300,000 piastres in damage to the rice paddies into 300,000 dead in Haiphong. You don't need to assume any bad intent behind that error. It could have been a translator working under time pressure. It could have been an editor who, condensing a long report, accidentally merged two lines from different paragraphs. It could have been an exhausted typesetter who dropped a key word while setting the text for print, the word that distinguished piastres from bodies. Whatever the scenario, the result was exactly the same. A figure for economic damage turned into a figure for human mortality, without anyone ever checking it against the original source. That figure, 300,000 dead, quickly made its way into the earliest international rankings of history's deadliest natural disasters. It made it into the Encyclopedia Britannica. Decades later, it made it into Wikipedia, where millions of people read it without questioning it. It got repeated in documentaries, in viral internet lists, in rankings of the worst natural disasters of all time, placing the 1881 Haiphong Typhoon on a podium ahead of the vast majority of earthquakes and hurricanes humanity has ever documented. And the most unsettling part of all this is that nobody seriously challenged that number for more than 130 years. It wasn't until the 2010s that a group of researchers began systematically cross-referencing the original colonial archives, letters published in the era's colonial newspaper, L'Avenir du Tonkin, private correspondence from French residents in Haiphong, administrative records held in overseas archives, against the figure that had circulated freely for generations in encyclopedias and popular publications. The discrepancy turned out to be impossible to ignore the moment someone actually bothered to look closely. Haiphong's total population in 1881 didn't reach 20,000 people. It was mathematically impossible for 300,000 people to have died in a city that didn't have 300,000 residents, not even counting several surrounding provinces. The number wasn't just exaggerated. It was literally impossible under any reasonable reading of the demographic data available for that period. Modern historical reconstruction, built on careful cross-referencing of these primary sources, places the real death toll in the Tonkin region at around 3,000 people, a figure consistent with the earliest colonial reports, before the mix-up occurred. Add to that several thousand additional victims, some sources say up to 20,000, in northern Luzon, where the same weather system had made landfall days earlier on its way to the Gulf of Tonkin. A real tragedy, a deeply painful human tragedy, but roughly 100 times smaller than the legend that circulated unquestioned for more than a century. This story, though, isn't just a curious anecdote about a 19th century translation error. It's also a story about how the exact same weather systems that produced that tragedy are still active in that exact part of the world today. The Gulf of Tonkin remains one of the busiest corridors for typhoons forming in the Pacific Ocean. The combination of factors that turned that 1881 storm into a catastrophe, warm water capable of re-intensifying a weakening system, a low-lying, densely populated delta, a coastal channel that acts as a natural funnel for storm surge, still exists today, exactly as it did then. The main difference now isn't the raw strength of the storms forming in that region, it's humanity's ability to see them coming. In 1881, the only possible warning was a ship making it to port before the storm and telling people what it had seen. Today we have weather satellites, numerical forecasting models, early warning systems capable of announcing a typhoon's arrival days in advance. And yet, even with all that 21st century technological advantage, modern typhoons like Haiyan, which struck the Philippines in 2013, still killed thousands of people in that same general part of the world. Technology has enormously improved our ability to see disaster coming, but it hasn't come close to eliminating the structural vulnerability of communities living on those low-lying, densely populated coasts. The real lesson the 1881 Haiphong typhoon leaves us isn't just about a false number that history repeated unquestioned for generations. It's also a lesson about how a real human tragedy, with thousands of lives lost, ended up overshadowed for more than a century by an invented number that simply happened to be more shocking, more memorable, more viral, long before that word even existed in our vocabulary. If the 1881 Haiphong typhoon actually killed around 3,000 people, and not the 300,000 that circulated for generations, it's worth asking an uncomfortable question. How many other 19th century disasters are still circulating today, in books, documentaries, internet lists, with numbers nobody has bothered to check against the original sources? If stories like this interest you, numbers that get repeated for generations without anyone stopping to question them, subscribe to the channel. We're going to keep digging into the stories the textbooks considered closed a long time ago, and that, as we just saw, were never really closed at all.